called linear functions. And I'm going to give a couple definitions, do a few examples. All of this can truly be done in the calculator, but you just need to know a couple of definitions with this. So first part, what is a linear function? Well, we just learned what a function is. That's that f of x notation, which is really just y. So it would be written as f of x equals ax plus b. This is your basic linear function. This will always make a line. The a and the b are numbers. This could be 2x plus 5. You never have exponents with the x because then you wouldn't be making a linear function or a line. The solution to this linear function is x f of x. Or if you remember, f of x is actually a y value. So x f of x. So I want to get that definition out of the way. Again, we'll do some examples in a minute. I just want to get a few quick definitions given to you. Locating x and y intercepts. Very important. You're going to be asked a lot of this on the homework. What's the x-intercept? What's the y-intercept? Okay? It's very easy to do, but it seems a little backwards. So if you want to find an x-intercept, you set the y equal to 0. And that will give you an x value. So like if you're thinking about it like a t-chart here, if you want to find an x-intercept, you put a 0 here in for y, or you put a 0 in for f of x. And that will help you find the x-intercept. If you want to find a y-intercept, you set the x equal to 0. So you put a 0 here, and then you would find out what the y value is. So they're kind of like flip-flop. If I want to find an x, I set the y. If I want to find a y, I set the x equal to 0. And you make this little table right here, and those are your x and y intercepts. Okay? So that's another quick little definition. And like I said, we'll do examples in a minute. You're also going to be asked this question called, what is the 0 of the function? They'll say that a lot. What is the 0 of a function? Okay. 0 of a function, it's just a fancy name for really x-intercept. Hint, hint, hint. Okay. When we start solving polynomials, we'll find the zeros, which are the x-intercepts. Okay. It's all, why did they switch names? I don't know. I teach the math. I didn't make up the math. But this is, it really is when you set your function equal to y, it's equal to 0, excuse me, your y equal to 0, and you find out what that c value is. So you're finding x comma 0, or in this case, c comma 0. You're finding the x-intercept. So you set the function equal to 0 and solve for x or solve for c or whatever. So that's called the 0 of the function. All right, so with this, let's do an example of something that you'll see on homework number 2. So it's going to ask you to graph f of x equals negative 2x plus 5 by finding its intercepts. And then it's going to ask you, what is the 0 of f? Oops, 0 of f. And I do want to do this one by hand. I mean, obviously, you can easily, to save yourself some time, you get a calculator, so we'll put it in the calculator in a minute. But just to show you how to do this by hand, it's really not that hard. But we're going to find its x-intercepts. So I always make a little chart here. 0, 0, 0's along the diagonal. And for this one, I'm going to set my y, or my f of x, equal to 0, and I'm going to solve it. So I'm going to have negative 2x plus 5, and I'm going to set that equal to 0. And so then if I subtract 5 over and divide by negative 2, I would get negative 5 divided by negative 2, which is positive 5 halves, or 2.5. So my x-intercept, because you have an actual x answer, that's your x-intercept right there. That is, hint, 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 another answer to this question. That's your 0. X-intercept, your 0. Okay, how do I find the y-intercept? You put 0 in for x. So you go 0 right into that function. Put a 0 into that function. So you would have f of x equals negative 2 times 0 plus 5. And of course that makes 0, so your answer is 5. That right there is your y-intercept. And then from there, you can graph the function quite easily. You know it's a linear function. So you can actually just plot 0, 5, 1, 2, 3, 4, 5, and then 2.5. 1, 2, 3, so 2.5 will be here. And then just draw your line. And that would answer all the parts of the question. Now, again, how could you do this in your calculator? Just to show you, making sure there's no crazy glare. There we go. This button right up here at the top says y equals. You click on that, and this is what should come up, y1, y2. Since we're dealing with a linear equation, we're going to do negative 2, and make sure, again, let me put this up here, you have to hit that negative button. Don't hit a minus. It'll say error syntax. You have to hit negative 2. So negative 2, your X button is located next to the word alpha. Negative 2x plus 5. And then I always tell my students your basic general standard viewing window, the one that goes 10 up, 10 down, 10 left, 10 right, is at zoom 6. Zoom 6 is your basic window. And you'll see, there it goes. And you can almost see, it's, hopefully you can actually count 1, 2, 3, 4, 5, and then 2.5. Oh, there's some people waiting in the lobby. Give me 1 second to let them in. Maybe they left me. Oh, I guess they left, or maybe they somehow came in. Oh, never mind. Okay, sorry about that. I'm all messed up on myself. All right, so hopefully that makes sense. Again, you can always double check this on the calculator. Pretty simple. Now, my dog is going crazy. Now we're going to do a quick, I don't want to say word problem, because I know every time I say word problem, people get scared. But it's pretty simple. It's writing an example of a fish tank, a 100-gallon tank full of water. My son and husband are home. Judah, can you shut my door for me? Thank you. Thank you. A 100-gallon tank full of water is being drained at a rate of 5 gallons per minute. You're going to have a question just like this, similar, and it's going to ask you 3 things. It's going to say, write a formula. And it's going to ask you to do it in function notation, so I'll show you how to do that in a minute. Then it's going to ask you how much water is in the tank after 4 minutes. And then I want you to graph X and Y intercepts and interpret each. So we will go through that. So here's a example. Don't freak out by this. This is really not that hard. Okay, so you have a 100-gallon tank full of water. It's being drained, that's important, at a rate of 5 gallons per minute. Okay, so we're supposed to write a formula. So rate is another word for, we're about to get into it, something called slope. And your slope is always located next to the x in an equation. So if we were to write a formula, we would have f of x, our function, is equal to the rate, the constant rate per minute. And again, we're draining our tank. So we're going to be draining it at 5 gallons per minute, or negative 5 gallons per x minutes. So every minute goes by, another 5 gallons. 2 minutes go by, another 5 gallons. 3 minutes go by, another 5 gallons for the total amount. And what did we have to start with in this tank? We started with a 100-gallon tank. So that would be our initial amount. So this right here is your initial amount. And that right here is the rate per X minute. So now we've written a formula. Pretty simple. How much water is in the tank after 4 minutes? Well, that's easy now that we have our formula. We just take the number 4 and we're going to plug it in for X. So we want to find out what the F of 4 is. Negative 5 times 4 plus 100, which would be negative 20 plus 100, which is 80. 80 what? 80 gallons. So after 4 minutes, this tank is now down to 80 gallons of water because it's going at a rate of 5 gallons per minute. Now we want to graph the X and Y intercepts and we want to interpret them. So again, there's this little chart that I did on the other page. I put a 0 here, I put a 0 here. Okay, so 0 for the Y, you're going to set this equation right here, this formula, equal to 0. So let's see, 0 equals negative 5x plus 100, and then solve for x. Negative 100 equals negative 5x, divided by negative 5 would be 20. This 0, you're going to plug in for x. So you're going to put a 0 in for x. And that's pretty easy. Hopefully you can just tell this would go away, go bye-bye, and you'd be left with 100. So I'm not even going to worry about working that out. Now from there, you will make a graph. And so our x-axis would be minutes. Our y-axis would be gallons. And I believe they give you choices to look like to pick the correct one. So be very careful. Make sure you're picking a correct one here. And let's see. We'll scale it by 20. We'll go 1, 2, 3, 4, 5. And then this one is 100 gallons, so we can go by 25s, or 25, 50, 75, 100. Yeah. And then 0, 100, that would be your y-intercept. 20, 0, that would be your x-intercept. And then there, that would be your graph. It should be negative because you're draining water. Water should be decreasing. And so you're trying to explain this. This would be, again, the coordinate 20, 0, or 20 minutes. At the 20-minute mark, I have what? 0 gallons left in my tank. At the 20-minute mark, I have 0 gallons. That's an interpretation. Up here, if I were explaining what this coordinate means, this would be the point 0, 100. Again, 0 being your minutes, 100 being your gallons. So at 0 minutes, I have 100 gallons, or I start with a 100-gallon tank. And that makes sense according to our story. So you'll have a question similar to this. Hopefully that makes a little bit of sense. And then that's how you would graph it and interpret the results. I think they give you a multiple choice, which is pretty cool. All right, moving on to what's called the constant function. Or I should say constant functions, because there's 2 of them. Okay, so I love charts. So I'm going to make like a 4-column chart here. Let's see. We'll do the graph, slope, equation, and then I'm not sure what to call this other one. I mean, actually, I probably should have said graph here, but you'll see what I mean in a minute. So you have 2 different constant functions. You have a horizontal line, and then you have the vertical line. Okay. So horizontal line, you know, a straight line going straight across, and then a vertical line going up and down. Okay. So write this out and then I'll give you a little phrase that a teacher friend of mine gave to me. I say it to all my students all the time, and I like it. It may not make sense to you. I hope it does, because I think it does make sense. But I'll explain what it means in a minute. The horizontal line looks like this. So here's a graph of it. Let's say there's your linear function, also known as a constant function. It's a line, so it is a linear function, but it is a constant function. This is the line, the equation y equals 2. Y equals 2. The slope of all horizontal lines, all of them, are 0. They all have a 0 slope. Okay? If I were to ask you questions like maybe from last week, if I want to refresh you, I'm trying to remember if they ask you, but we'll do it anyway. If I said, what's the domain? How wide is this thing getting? If I were to keep going out into forever and forever, how wide was this thing get? And you're like, well, it's gonna keep going on and on and on. How wide? Well, from negative infinity to infinity. And if I said, what's the range? How tall is this thing getting? Well, it doesn't seem to get any taller than this point right here. There's nothing below this point. There's nothing above this point. What's the range? What's the y values of every dot that I see? They all have a 2. And that would be your range. So that's a horizontal line. Then we have a vertical line. The vertical line would be like this. And the vertical line, all vertical lines, all straight up and down lines are written as x equals a number. X equals what? Well, this would be -1, -2, -3 on the x. So x equals -3. The slope of all vertical lines is no slope. Some books say undefined. Okay, there is a huge difference, please know this, between zeros and undefined. Zero slope or no, and then no slope. They're two different things. And again, if I were to ask you the domain, how wide is this thing getting? What are all the x's? Well, the only x values that you have from each of these dots right here, they all have -3. The range, how tall is this thing getting? Well, it's going off and off and off and on. So it's going from -infinity to infinity. Now, this can get very confusing to students. They miss this up all the time. I've heard several people say it different ways, but like I said, I have a teacher friend of mine and she uses this phrase and I like it. So you can write it down. And it's hoi vernox. Hoi vernox. I know it makes absolutely no sense until you actually look at this. Horizontal lines have zero slope and are always written as y equals. Horizontal lines have zero slope and are always written as y equals. Vernox stands for vertical lines, have no slope, and are always written as x equals. So, hoi vernox. I don't know if you like it. I like it. I think it works for me. But feel free to think of it however you want. All right. Getting to the end of this lovely section here. We're going to finish off with slope and graphing some lines on the slope intercept form. And then that should be the end of 1.3 for the minute. Oops. Okay, so let's talk about slope. Hopefully you are very familiar with slope. You have seen slope so many times. So slope is usually written with a lowercase m. That's your slope. It is your delta y over delta x, or delta in science and mathematics means change in y's and your change in x's. Change means subtraction. So you take y2 minus y1 over x2 minus x1. So that would be your slope formula, y2 minus y1 over x2 minus x1. Okay, and real quick, going back to the zero and the undefined, like how do you know if you're working through a problem and you get a zero slope or an undefined slope, which I always think is a great question, so you might want to write this over here. You are always allowed in mathematics to have zero in a numerator, and then you would always have a number in the bottom, like a 1 or a 2 or whatever. Zero on top is zero slope. Zero on top is a zero slope. Zero on bottom is never allowed. We don't ever divide by zero. It makes no sense to us. So zero on the bottom would mean that you have no slope or you have a vertical line, hoi vernox. So zero on top, that's good. That's zero slope. Zero on bottom, that's a no slope. So it's just something to remember, just something to write down in case you get a problem like that. So we're going to do a couple of these examples on slope that I saw on your homework. So real quick, just to review how to find slope. Find the slope of the line through the points 2, -1, and -5, 3. That'll be part A, because you know there's always multiple parts. And then part B will be graph the line through the point 2, 1 that has a slope of negative 4, 3. So we'll do those together. So again, I'm a firm believer on like labeling things, like when we did the distance formula last week. I would label this as my x1, my y1. And then this point would be my x2, y2. It doesn't matter, honestly, if you were to label this x2, y2, but you have to stay consistent. Like, don't be like x1, y2. That doesn't make sense. Okay, x1, y1, x2, y2. And now you're going to put this into the formula. Just be careful. I get this every year. I don't know why, but I always have students put x's on top. That's not what goes in first. The first things are your y's. So y2, which would be 3, minus y1, which is a negative 1, over x2, which is negative 5, minus x1, which is 2. So 3 minus negative 1 becomes 3 plus 1, which is 4. And then negative 5 minus 2 is negative 7. And again, I've shown you how to put this as a fraction in your calculator. If you just want me to show you the trick again, if you hit alpha and then window, I believe it is, you see over here where it says frac, move the cursor over, and the first thing is n/d. And then right in here, you can actually just type what I had written here, 3 minus negative 1, and on the bottom, negative 5 minus 2, and you'll get negative 4/7. I mean, it can do it for you. If you have fractions, I think I saw some fractions on there. I know we're going to do fractions in a minute. This one, graph the line through to 1 that has a slope of negative 4, 3. Okay. One more thing about slope, and I didn't write it up here in the definition, but I'm hoping you remember it. Maybe it'll sound familiar from high school, but your slope is your rise over your run. Your rise over your run. So if I want to graph a line through the point 2, 1, I'm going to find the point 2, 1. 1, 2, 1. I'm going to make a dot. And then I am going to go in the direction of my slope and create another dot when I rise and when I run. Now, here's the trick with this one. I'm rising negative 4. And by the way, the negative might be on the outside. Always bring it to the top. Just always make it go up to the top. If I rise negative 4, what does that really mean? That means you go down 4. 1, 2, 3, 4. And then you run 3 spots. 1, 2, 3. And right there, you've created a line. You can do it again. You could actually do it the opposite direction. You could go up 4. 1, 2, 3, 4. 1, 2, 3, 4. But then you would have to go left 3. 1, 2, 3. Okay, so rise, if it's negative, you would go down. So the top, you always go up or down. And again, if you had something like negative 4 over 3 like that, that negative, I always just make it go to the top. I always, always, always make it go to the top. And then the bottom is whether you go right or left, but I always go to the right unless I'm doing the opposite of what I had done before. I think one other thing to tell you, if let's say you get a slope of 7, I won't say equals, 7, just so you know, is always over 1. So you would rise 7, run to the right 1. Rise 7, run to the right 1. And so you'll have to do a quick, easy problem like that. I don't think it should hurt you. That's like algebra 1 stuff that you probably are familiar with. All right, and then another quick little word problem, nothing too crazy. This one is, let's see, by noon, 5 inches of rain fell in a storm. And then it said rain continued at a rate, there's that word again, of 1/2 inch per hour. So the first part, write a linear formula. Part B, find the total amount of rain at 2:30 p.m. And is that it? That's it. Okay, cool. All right, so by noon, 5 inches of rain fell in a storm, and the rain continued at a rate of 1/2 inch per hour. So we're going to let X be obviously the total inches of rain. And so we're going to start from noon, since that's where the problem is starting. So this rate of 1/2 inch, that is your slope. Slope and rate are synonymous. So if I'm going to write in linear formula, I would say f of x equals 1/2 inch of rain per hour. And I originally started with 5 inches. Now, again, I know this is at noontime, so that's where our time is starting. This would be my linear formula, 1/2 times x amount of inches plus 5, which was my initial amount. Then the question says, find the total amount of rain at 2:30. So we are working with time here. How much time has transpired from noon to 2:30? How many hours, since we're talking about inches per hour? Well, again, we don't want to convert it to minutes. So from noon to 2:30, how many hours would that be? That would be 2.5 hours. So we want to take the point 2.5 and plug it in for x. And then f of x being our total amount of rain that we would get. So if I plug 2.5 in, so f of 2.5 equals 1/2 times 2.5 plus 5. And I believe with the magic of my calculator brain, you get 6.25 inches of rain total at 2:30 p.m. So there's going to be a question like this. They're going to have a time on it, like they might say starting at 1, and then you got to be careful here. Where did they start from 1 o'clock or from noon in this case? From noon, I started 2.5 hours later, 2:30. And that's what I would plug in for x. X being 1/2 inch per hour. This would be my hours. That's my rate per hour. And then there's my initial amount of inches. And you'll pretty easy, you'll fly through it. A question like that. All right, last and final things for this section. And then let's see. Oh, look at that. Not too bad with the first section. Almost done here. We're going to talk about the slope-intercept form. This is, I think, 6 I'm on. Slope-intercept form. So slope-intercept form, I'm going to switch now to not writing it in function notation. I'm going to write it with y's. But your slope-intercept form is y equals mx plus b. And the reason why it's called slope-intercept form is because this is your slope. The number in front of x is always your slope. And this is your y-intercept, where it intersects the y. And it's usually written as a coordinate 0 and then whatever that number happens to be. If it's a 5, it'd be a 5. Okay, so this is your slope-intercept form. And we're going to just practice graphing a few of these. Again, I know you can do this on your calculator, but I just want to make sure that you can feel even more confident by doing it out by hand. But if I gave you y equals negative 2x plus 3, and then y equals 3/2 x, and then y equals negative 7 minus x. Okay, and again, show you how to put them in the calculator in a minute, but I'm sure you can all figure that out. But this again is your slope, and this is your y-intercept. This is actually where you start your graph. You start here. You start at 0, 3. So I would go to 0, 3, 1, 2, 3, and make a dot. That's your starting dot. That y-intercept is your starting dot. Slope, again, is rise over run. Rise over run. So make it a fraction. Right now it's negative 2. Put it over 1. So I'm rising negative 2. I'm running 1. Or in this case, I'm going to go down 2, right 1. So down 2, 1, 2, right 1. And make a dot. Down 2, right 1. And make a dot. And then you can keep going. Usually 3 points is good enough. But if you plug that in your calculator, negative 2x plus 3 into the y1, you'll get that graph. What about this one? Y equals 3/2 x. Where's the b? Well, it's 0. There's nothing after it, so we can call it 0. So that's where we start. That's the y-intercept. 0, 0. And so draw my little axes here. I'm going to start right there at 0, 0. And my slope, again, I rise 3, I run 2. 1, 2, 3, 1, 2, make a dot. 1, 2, 3, 1, 2, make a dot. And you can go the opposite way, down 3, 1, 2, 3, left 2, 1, 2, and you should still land on the line. Last one, negative 7 minus x. Now they kind of did this on purpose. They switched it. You can rewrite it if you want to. Negative x minus 7. The slope is the number in front of x. In this case, it looks like there isn't a number, but there is. It's negative 1. There's always an understood 1 value in front of something. Again, you could stick it over 1. Because you always want slope to be a fraction, because it's a rise over a run. And then this point here, this negative 7, is where I start. That's my y-intercept. It's kind of down here, actually. 1, 2, 3, 4, 5, 6, 7. And I'm going to go in the direction of my slope. So I'm going to go down 1, right 1, down 1, right 1. Because again, I like to put my negative always, always, always on top. Down 1, right 1, down 1, right 1. Or opposite direction, up, left, up, left. And so here you'll have your lovely graph. Again, easy, easy, easy to do on the graphing calculator. I'll just do this last one real quick. You can even type it the way it is. Negative 7 minus x. Hit zoom 6, because that's your basic standard view. And look, there you go. You're down at negative 7. You can actually see where the other intercept is. The other intercept's at negative 7 over here for x. I'll show you how to find a table very soon. You can actually look at a table. Let me see if it'll come up right now. And it'll give you all the x and y coordinates. So that's pretty fun. We'll save that for another time, though, unless you already know about it. But there's your graphs. And I just want to do one more quick example of this for you, and that would be it for section 1.3. But, oh yes, they're going to give you a graph. So let me just give me a minute to draw it right here accurately. And let's see. Here. Here. And they'll have some points on the graph. So this is what they're giving you. They're giving you a graph, and obviously it'll be much easier for you to tell. And from the graph, you need to determine the following things. You have to tell me the slope. You have to tell me the x-intercept and the y-intercept. You'll have to write an equation for f, and then find any zeros. Okay, so don't freak out. This is not hard. Slope is easy. Slope is the rise over the run from 2 points. Okay, so it's your rise over your run. So, I mean, you can start right here in the middle. What did you just rise to get to this next point? I'm going to go from here to here. Could you have started here to here? Sure, it doesn't matter. Could you have done this one to that point? Sure. It's all going to be the same ratio. So my rise looks like it's 1, but my run is left. Listen to what I'm saying direction-wise. I went up 1, and then I went left 1, 2, 3. So now I put that negative on the bottom, which really is the same as pulling it out to the front, which is the same as pulling it on top. These are all the same thing. This one is the one probably most preferred, is having the negative out on the side, but they all mean the same thing. So you could have done that right here too. You could have done it backwards. You could have said, oh, look at that. I went down 1, right 3, down 1, right 3 would have been that one. They're all the same. So slope isn't hard. Just pick 2 points and write the ratio. X and Y intercept. So your x-intercept would always be an x value and then 0. Your y-intercept would be a 0 for x and then some number y right here. So x-intercept, where is it crossing the x-axis? It's crossing right there. And what is that point? That's the point -3, 0. Where is it crossing the y-axis? Right here, the y-intercept, which is 0, -1. So easy peasy. Write an equation for f. This isn't hard at all either, because we just learned this slope-intercept form, mx plus b. Your slope, put an x, and then add your y-intercept. So they want it in f notation, so we'll just give them an f. So slope, and then put an x, and then put plus b, whatever your y-intercept was. So let's see, our slope, we just got up here, was -1/3. And then our b value, the y-intercept, is at -1. So pretty simple. And then last but not least, find any zeros. What is zeros again? What does that mean? It means x-intercepts. X-intercepts. And we usually don't write the 0. We just write the x-intercept, what that was. And that 0, -3, 0. Don't write the 0. Just say the 0 was -3. Okay, and that, my